Engagement Series seminar, and as you see the title there, it's on Canada's opportunity to become a sustainable energy superpower. My name is Johnny Zook. It's not a lot of fun. One of my areas of responsibility is the Ontario Centre for Engineering and Public Policy, which is known to you people as Ocepp. And before I move on, I'd like to recognize the director there, Bernard Ennis, who couldn't be here today. And as we all know, directors and deputies don't really carry a lot of the load or don't do much of the hard work. So those that really need to be recognized are Catherine and Josie at the front end there. They're definitely the people that make the machine turn. So I apologize for my baritone voice. I just seem to have picked up a small bug along the way this week. I also want to acknowledge Gary Thompson's here from the advisory board. Ocepp has an external advisory board. People like Gary volunteer their time on it, and they help make sure and ensure that the mandate of the Ocepp is being steered accordingly. A little bit of history on Ocepp for those that don't know us. Ocepp was created by P.Eng in June of 2008. Basically as a means to engage engineers and others in discussions of issues at the nexus of engineering and, of course, public policy. The Centre's Policy Engagement Seminar, one of which is today, it's an important part of that mission. It's a vehicle we find that has become very useful. And these seminars aim to bring legislators, business leaders, and policymakers together with engineering experts to examine important engineering and, of course, public policy matters. So not only do these seminars offer, we hope they do anyway, offer insight into topical issues in the engineering perspective, they also present a special opportunity for engineers to communicate their expertise to an influential audience. We hope that all Ontarians will benefit from some of these seminars, and we're also very hopeful that many of you will want to contribute in some of the other facets of Ocepp, which includes publications and professional papers that will get published in PO's Engineering Dimensions magazine. Take a little bit of the focus away from the blue pages, so I know a lot of the engineers like to turn to those pages, but certainly there's a little more to life than the blue pages. This year's conference, on an annual policy conference that we try and carry out every year, is being held at Toronto on Friday, March 31st. We'd like you to note that date. We'd be delighted if some of you, or if all of you, could attend. We've got some pretty good keynote speakers, one of which is TV Ontario's host, Steve P.Eng, and as well as Don Ilika, who's a senior associate at Canada's Public Policy Forum in Ottawa. Steve P.Eng will talk about what keeps Queen's, it's a good one, what keeps Queen's Park up at night, while Don Ilika, he'll discuss the importance of building stakeholder engagement, which is part of the focus of seminars like this, is to get people involved at the early stages before you come up with a solution that nobody else really seems to support. The full conference agenda, of course, will be up on our website soon. And if you'd like any of the updates with Ocepp or anything, feel free to send us an email, or you can hook up on Facebook. I understand, according to my notes here, there's at least 18 million Canadians on Facebook, minus one. My kids prohibit me from getting on Facebook for, I guess, fear. Before I introduce today's presenter, who's right in front of me, and he's asked me to keep his presentation to a brief minimum, that's why I'm dragging out this wonderful speech that's prepared for me. Please note that the PDF version of today's presentation, as well as the video recording, it will be accessible on our website. With today's multi-featured technology, not only can you live it live, you can relive it if you weren't alive at the session. So without further ado, I just want to say that today's guest speaker is Professor Richard Marceau. He's currently Provost and Vice President of the Academics at the University of Ontario Institute of Technology. For those of you who don't know, that's that little school that will and would and does out here near Oshawa. Happy to know that Mark Rosen, who was once Dean there or Chairman, I was doing my Master's, he was doing his PhD, so he moved faster. Richard's also President of the Canadian Academy of Engineering and a registered professional engineer both in Ontario and Quebec. He began his engineering career with Monenco Inc. in the late 70s later becoming a researcher at the Hydro-Quebec Research Institute and founding editor of the IEEE Canadian Review. After earning his PhD from McGill University, Richard accepted an assistant professorship at l'École Polytechnique of Montreal, and subsequent promotions included a full professorship in 1999, and 2 years later, appointment as Dean of the Faculty of Engineering at the University of Sherbrooke. Since joining UOIT in January of 2005, he's contributed enormously to the university's development, including the launch of the first master's and doctoral programs, and the establishment of its Energy Systems and Nuclear Science Research Center. Other career highlights include securing millions of dollars in research grants. If you don't know, when I was going to school, those were easy. Ottawa used to send the money. Now I understand you got to do a lot more than that just to get money. And as well, he's had enormous publications, 21 peer-reviewed journal articles, 37 conference articles, and 3 books. And to boot, 5 patents, including OIT's first patent. On June 1st, Richard will take up a new challenge as Vice President of Research at Memorial University in Newfoundland. Please join me in welcoming Dr. Marceau.
Thank you very much for these kind words, Johnny. I must say that I have a feeling that your job is like the provost's job. I see the worst and the best, and usually the worst. Before I begin, I can't say how honored I am to be here today, to be invited to make a presentation before my peers, and I want to express to Catherine and to Ocepp and to the PEO my deep gratitude for this invitation and how honored I am to be here today. I'm just going to do a little something here. I'll bring this back up so that we can fire up the presentation. And we will get this going. Now, what I'd like to say to begin, this presentation will attempt to summarize the 200 pages of this book that you can download for free from the Canadian Academy of Engineering website. It's a bit of an edgy title, and it's edgy because we're trying to catch people's attention. And I'm doing this presentation on behalf of myself and my co-author and co-editor of the book, Dr. Clem Bowman, and I'll speak to you about him later on. So, what is the fundamental thesis of this book and this presentation? The answer is, today we remain hewers of wood and drawers of water. We sell our natural resources to the highest bidder, and if we want to be more than a superstore of energy resources in the world, we need to move on to creating value-added products from our raw natural resources, and in the case of energy, our raw natural energy resources. And that's the fundamental idea that I'm going to be hammering on over and over again today. If we stand still and continue to be a superstore, we will give wealth, we will give opportunity, we will give the future of our country away to other nations who are doing their own nation building. If you go to China today, there's a lot of nation building going on in China. If you go to India, there's a lot of nation building going on in India. In a country like Canada, where 95% of our country is still just an idea or an opportunity, where we can barely maintain our sovereignty, we can still do a lot of nation building. So how do we move forward? Well, if we're talking about taking raw energy resources and making them into value-added products, we're talking about innovation. And the conventional innovation process is that you do research, you apply it, you come up with something that may be commercially applicable, but Canada's no good at getting ideas out of the lab, and even pre-competitive ideas out of the lab and in the market space. However, when we look around ourselves, why is it that we have a quality of life that is comparable to those nations who do it the best? There's a disconnect there. We are doing something right. We have been doing something right for a long time. And what is it that we've been doing? And the fundamental thesis that I would like to present today is that Canada does have a very successful, an outrageously successful innovation strategy that we at the Canadian Academy of Engineering, we call it the Big Project Innovation Strategy, which is a Canadian strength. Big projects have been the way that we have built Canada over the past 200 years. It has helped us establish our sovereignty. It's strengthened our Canadian national unity through all kinds of infrastructure, communications, transportations, energy. It has created competitive advantages, but more importantly, it has not been based on short-term economics, and the big projects that we have done over and over again in this country have created an innovation ecosystem that has given our country a razor-sharp focus at various moments of our past to push things forward and create a whole cascade of impacts in industry and in our society that have given us commercial advantages and made us the country that we are today. It has not always been government, and I will make that point very clear in just a few minutes, but big projects have changed the economics of all other future projects, as you will see in a moment. Now, this presentation is not one presentation. It is 22 presentations that I will make in the next 25 minutes. I will present 12 big projects of the past. I will present 9 big projects that we are proposing that could be done right now, all the way to 2050, that would change the face of Canada. And the 22nd presentation is the one that I'm trying to do right now, trying to bring it all together for you in less than 25 minutes. So I'm going to whiz through this. It could take me a lot longer, but I'll go through this very quickly, and I'll be very happy to answer any questions that you may have. So let's go through these 12 big projects of the past. First of all, there's the Rideau Canal. It was created to create an internal line of communication and movement of people and equipment from a military perspective in the 1820s. And yet, what it did finally, it was never used in war. It was used to move people westward and goods from Canada's hinterland eastward, and it developed Canada's economy and settled southern Ontario. And that was financed by the British government, by the way. Now, the second big project was a private project financed primarily by the Grand Trunk Railway, but with a significant incentive in actually risk sharing by the Canadian government in the 1850s. Goods would get to Montreal. Once they got to Montreal, you had to load them on a boat. In order to accelerate the transfer of goods from Montreal to the eastern seaboard of the US and to Europe, you needed to cross the St. Lawrence. And the St. Lawrence was crossed during winter on an ice sheet. But after losing many locomotives and many people through the ice over many decades, they decided to build the bridge. It was the longest bridge in the world. The Prince of Wales was there to inaugurate it. It was considered the 8th wonder of the world. It made Montreal a continental hub and secured a trade route from Montreal all the way to the eastern seaboard, which greatly accelerated Canada's development. The CPR was also a private project undertaken with significant government risk-sharing agreements, from land grants to loans to actually outright financial grants. One characteristic of great projects is that they are always controversial. They are never unanimous. People will be for, people will be against, but they require leadership to get them up and going and leadership to get them through. And lots and lots and lots of engineering to make them, because all these projects required technology that we didn't have, knowledge of all sorts of areas that we didn't have, and yet we got them done because they needed to be done for reasons that went beyond short-term economics, which is why government risk sharing is so important in some of these projects. So here we see that it was, the CPR was BC's condition for coming into Confederation. But without the CPR, there would have been no Alberta, there would have been no Saskatchewan. They might have been American today, because had they not been settled by the CPR, there would be no united Canada from sea to sea. Another one was Trans-Canada Airline in the 1930s. In the 1930s, there was a huge push to accelerate the movement of people and goods from one end of the US to the other. And people in Canada were very sensitive to this, and a lot of the airline development was done in the US thanks to the use of the postal requirements soared in the 1930s, and the US government used airline travel to subsidize, used the US Postal Office to subsidize the airlines. But in Canada, we didn't have a strategy, we didn't have a policy, we didn't have a vision for that. But people wanting to go from one main Canadian city to another, except for Montreal and Toronto, could not do so by going through Canada. They had to go through the US. So we built most of the airports that we know today as make-work projects during the Depression, created TCA as a Crown Corporation, a subsidiary of CN Railways, and thanks to that beginning in 1935, what happened is it rapidly created a Canadian aerospace manufacturing capability, which helped us build Mosquito bombers, Lancaster bombers, Hawker Hurricanes, and many other types of planes during World War II. And that has created Canada as the third largest manufacturer of aerospace equipment in the world today. So that investment as a Crown Corporation, as an operator, had a significant cascade effect throughout Canadian industry. Polymer Corporation, that was established as a Crown Corporation. Again, in 1942, by June of 1942, Japanese had taken over 1/7 of the surface of the globe and cut off the Allies' rubber supply, natural rubber supply. There needed to be a source of synthetic rubber. All that existed at that time was a tabletop notion of something that might work. And this tabletop test tube idea was scaled up to a massive industrial plant, and this plant supplied most of the rubber used by the Allied forces during World War II. Tanks, jeeps, airplanes, gaskets, engines, all of it was thanks to synthetic rubber. Couldn't have done it without it. By the way, is anybody chewing gum right now? Yeah. 100% of the world's chewing gum is manufactured today by this plant as an offshoot of the synthetic rubber operation. This was so successful, this Crown Corporation made so much money that it was on Canada's $10 bills for decades. The St. Lawrence Seaway. After World War II, Canada was an industrial superpower. We simply, even though we had two Trans-Canada railway systems to carry goods to and fro the two oceans, we simply did not have enough capacity to get our goods out to the rest of the world, whether they were raw resources or manufactured goods, and to bring goods back into Canada. We needed more capacity. We built the St. Lawrence Seaway. We did it in partnership with the Americans. It was a great project. We paid about 2/3 of it, but we got a lot out of it, as you'll see here, and billions of metric tons of goods moved over the past 50 years, and 2 gigawatts of hydroelectric power in a first joint international hydroelectric power plant. Atomic Energy of Canada Limited and the AECL Crown Corporation. In the 1950s, Ontario needed a soaring amount of power. The electric power needs in the late 50s, early 60s were on the order of 5 to 10%. There are some people who remember those halcyon days. and in some provinces like Quebec, they were predicting 7% growth up until 1972. When you go back to 1953-54, when Ontario Hydro was looking at the options, they had 3 options. They had the option of bringing some hydroelectric power in from James Bay, or building thermal power plants, or using a new nuclear technology that hadn't been proven, hadn't been used by many people, and but that was wholly Canadian made. Well, the long distance transmission didn't work because we didn't have anything higher than 300 kV in the 1950s. Thermal power plants and nuclear power plants were assessed, and they seemed to be roughly equal at the time. And because the nuclear technology was Canadian, they decided to go for nuclear technology, Canadian nuclear technology. Today, without the CANDUs, I don't know what we would be burning to produce electricity in Ontario. It's even hard to know whether we would have built the capacity of low GHG generating power plants in the 1970s and 80s, because even then we already were very sensitive environmentally about carbon footprint and those things. So these CANDUs are the basic motor of Ontario's economy today, and have been for the past 50 years. So very important Crown Corporation, very important initiative in Ontario, and Ontario has been carrying for many decades until recently. It's been the economic heart of Canada, and it's carried Confederation through the equalization payments for a long time. So that is one of the motors of this very successful province. Of course, nuclear power is controversial even today. And when Trans-Canada Pipelines was set up as a Crown Corporation in the 1950s, how many of you remember that? A Crown Corporation. It was so controversial that the Liberal government fell, and that ushered in a new era. But today, a significant portion of our energy autonomy is based on this pipeline network. And what you see on this slide, but what you would see in far more detail in the book, is that Trans-Canada Pipelines has a pipeline network that goes deeply into the US. And the really funny thing about Trans-Canada Pipelines is that we buy gas and oil from Alberta, virtually on a daily basis. What's really funny is that in Alberta, they can't build a transmission line between Calgary and Edmonton because it's so difficult. so we can't build pipelines easily outside of Alberta, and they can't build transmission lines easily inside of Alberta. That's the way it is. Trans-Canada Microwave. In the 1950s, Canada, in 1958, had the highest quality telecommunication system in the world. And not only did it help business, not only did it help people connect with loved ones throughout the country, it brought Canada together. We all watched Hockey Night in Canada together on Saturday nights for decades. And this is the vehicle that made it happen. And this was a private enterprise initiative, but without that Hockey Night in Canada contract, it wouldn't have been done. Bell Canada knew how much money it was going to make from that one contract when it turned the switch on. So here's another example of private enterprise doing something, a massive project with Nortel Networks microwave technology that wouldn't have been done without government risk sharing of a certain form. Alouette, same thing. Alouette was an incredible initiative. It was financed entirely by the Government of Canada. What it did was establish the fact that Canadians could build satellites that worked, that were high quality, and that led to the formation in the early 1970s of a very different company, Telesat, which was a private enterprise, but which was where the founding shareholder was the Canada Pension Plan. So there is again another form of private enterprise initiative with government risk sharing involvement. James Bay. Now, hydroelectric power has been a long time part of the Canadian landscape. The James Bay project here is mostly as a placeholder. It's arguably the largest of all Canadian hydroelectric projects, but we have done massive hydroelectric projects throughout Canada, and the massive projects that we have undertaken, such as Niagara Falls, they were massive for their time. Big projects for their time. This was done by a Crown Corporation. Canadians are good at this. It's low GHG power, and it has had significant economic impact for Quebec particularly, but indirectly for other provinces who have imported some of that power. And the oil sands, again, very, very controversial. You know, the James Bay project was far more controversial in its time than the oil sands at the same time. And I remember Bobby Kennedy Jr. going to James Bay, you know, criticizing that initiative, you know, while the oil sands seemed to be okay. Cronenbowman, my co-author and co-editor of this book, was the head of the Alberta Oil Sands Research Authority in the 1970s. And he led the charge for developing the technology that is in use today, commercially in use today, for all of the oil sands recovery of bitumen. If he was standing here today, he would say, I think we did a great job in the 1970s. I wish we had known what we know today. We would have done it differently. He's the man that led that charge on behalf of the Alberta government. And by the way, the Alberta government owns all of that IP, but they license it to Suncor, to Syncrude, and all the others. But the man who led that charge would be here saying, if we knew about greenhouse gas, how it would impact climate change today in the 1970s, we would have done it differently. So these people they're not monsters, they're engineers doing the best they can at the time with the information that they have. But today, the Suncor oil sands are a significant impact on the Canadian economy. And I'll come back to that in a moment, because I'll talk to you about the future. So that's the past. So when you go down this list of 12 projects, some are government, some are private initiatives with government risk-sharing agreements, some are crown corporations. Let me summarize that for you. At their inception, the financial structure of these projects was one, financed entirely by government, the British government, the Rideau Canal. 6 were crown corporations. 5 were private enterprise-driven with government risk-sharing incentives. No big project was undertaken by private enterprise on their own. Not one. Today, the picture is one still owned by government, the Rideau Canal. There are 2 crown corporations left. All the others have been privatized. And the reason for that is that when you dig down, Trans-Canada Pipelines was sold off after government proved that it could be done and had opened up a completely new industry in Canada. Air Canada was privatized after they had begun a new industry in Canada. Polymer Corporation was privatized after that had begun a new industry in Canada. Not a new company, a entirely new industry. And the same for AECL. And there's still no competitor for ACL in Canada, though there are external competitors on the world stage. So this is very interesting. It simply proves the point that, 2 points. I hope I've made the case right now that big projects are the Canadian innovation strategy. This is the way we move our country forward. And when government has made a big project work through whatever financial structure that makes sense for that particular project, the role of government is either to sell it off as a crown corporation to private enterprise, or let private enterprise continue what it does, and then move on to the next one. And that's the problem. We've stopped the process. We have not moved on to the next one for some time. So, I've said a few words about the drivers of big projects. I'd just like to reiterate that they provide a razor focus for limited financial resources. Now, I shouldn't say that none have happened. I like to think that the hydroelectric project in Northern Ontario that was initiated in partnership with First Nations is an example of the kinds of big projects that could be undertaken in a creative way. However, we need more of these. And that's really the main message. So at the Canadian Academy of Engineering, we've been thinking about what we could do. And so how do you begin framing what should be the next big, really massive projects that would move us from being a super store to a superpower? And we've come to the conclusion that you have to add two more requisites to our spec sheet. We've got to ensure that we're lowering carbon footprint in Canada overall, and that we're aiming to upgrade raw energy sources into higher value added energy resources. I would add another thing. While we're aiming to reduce greenhouse gas production, we can develop the technology to reduce greenhouse gases in the atmosphere, regardless of what we do, provided that we can do so from a position of wealth. If we are too poor, we will never be able to develop the technologies that will help us transition to a low-carbon future. So we need to transition. This is Richard Marceau speaking. You may or may not agree. I'm deeply concerned about climate change. I'm deeply concerned about the accumulation of atmospheric carbon in the atmosphere. But I don't think we can do it if we're poor. So we need to transition smoothly and smartly without hurting our economy, and preferably by enhancing our economy so that we can once we continue to be in a position of wealth, and Ontario isn't quite there today, we need to invest in technologies that will drive down very aggressively carbon footprint accumulation. And I would even add, begin the process of depleting carbon in the atmosphere. And that's another thing. So here are the 9 projects that we have come up with, and I'll quickly go through them all. And many of them, probably all of them, will be controversial. So I'll start with the ones that are maybe, hopefully, least controversial, and I'll work my way to the most controversial. The St. Lawrence Seaway. You all know that Lake Huron, Georgian Bay are well below their historic levels. This can be corrected. We can decouple water levels from water flows very nicely. In fact, what is proposed here is something that was proposed in the original St. Lawrence Seaway construction plans, but these are water control infrastructure that were not made because we didn't need them to control water in the 1950s. We had enough water that we could spill water and control flows throughout the seaway without having to worry about levels. Had more than enough water flow. Today that's not the case, so what we're proposing is 5 new structures, 1 around Sarnia, 2 around Montreal, 1 at Sorel, 1 Quebec. And that would enable the St. Lawrence Seaway to decouple its level of water from the flows, the reduced flows, and still protect thousands of kilometers of wet shorelines and the natural habitats and the cottage areas of 150 million people. And that would cost $5 billion, and to boot, it would create another 1,000 megawatts of hydroelectric power.
Your structures are dams, is that what you're talking about?
Yes, dams and locks to enable ships to go through the seaway. Another big project is what we call Northern Waters. Now, here again, very controversial. I've just spoken to you about how we can make sure that the water levels of the Great Lakes return to their historic 1950s level. But we still have the problem of the St. Lawrence Seaway, the St. Lawrence River itself, which does not have enough water flow in it. And that can be corrected by doing 2 things. By taking the Waswanipi River in northern Quebec, over here, this is the Waswanipi River, diverting it into the Bell River. In other words, using the Bell River bed to pump this water up to Val d'Or and into the Ottawa River Valley. So the Waswanipi River goes upstream here, the Bell River dumps here. Together, we take part of this river here and all of the Bell River and put it in the Ottawa River Valley. Now, you're going to say, this is absolutely crazy. I mean, what did he smoke this morning? Now, what that does, now you're all engineers, you'll understand what I'm going to talk about. We have to pump that water, the Waswanipi River, 53 meters. And the Bell River, very little, really. We pump that into the Ottawa River. Then the Ottawa River falls ahead of 300 meters. The net head for this additional water is 250 meters, roughly. So, with the existing power stations on the Ottawa River, you could upgrade them by 3,000 megawatts and have 3,000 additional megawatts of electric power on the Ottawa River. Now, this whole project would cost $14 billion, which is a high cost for hydroelectric power. However, first you have to factor in the fact that all of those power stations on the Ottawa River now have to be maintained and restored. We're going to have to pay to bring them back up to a level that will enable them to work for another 50 plus years. So we're going to have to pay somewhere in the order of $5 to $7 to $8 billion just to do that. So that cost is there. What's left is gravy. So this is another big project.
Question.
Yes?
Where do you get power to do pumping?
It's part of the whole. It's part of the whole net. You have to have electricity to pay for that. But the electricity would come from,
The hydro
yeah,
stations on the water.
that's right. Well, there's a net gain, yes, of 3,000 megawatts. The power is there. Yeah. It would probably come from the James Bay system. The two networks aren't interconnected yet, but I'm going to talk about that in a minute. So another big project. What if we were to decarbonize the electricity systems in Canada? Now, using data from 2007, this is a notional idea. When we did this study in 2010-11, we were working with the best data that we had at the time. The idea is as follows. In 2007, the landscape has changed a little bit, but the idea is still sound. You've got 35 gigawatts of thermal electric power in Canada. There are at least 35 gigawatts of known hydroelectric, hydro-isolated projects that are on a variety of books throughout Canada. You could easily decarbonize the two by phasing out the thermal power plants, as noted here, in Nova Scotia, New Brunswick, Quebec, Ontario, Manitoba, Saskatchewan, and Alberta, and BC, with 35 gigawatts of low GHG hydro in Newfoundland, Nova Scotia, Quebec, Manitoba, and even possibly the Northwest Territories. Now, those power stations would cost about $52 billion. We're going to have to phase out the thermal or overhaul them over the next 20 years anyway. So there's a cost there that's going to be there anyway. So the question is, do we phase them out, use them for, say, voltage control, and bring power in from somewhere else? Or do we just overhaul them locally and maintain our high GHG footprint? That's the question, but this is the proposal. Can we decarbonize? The answer is yes. We've got the potential. We could do it. However, there's a piece missing in here. That's the transmission system. So let's talk about the transmission system. How do you connect it? Well, we looked at how we could connect it. So the idea is where you've got the isolated hydropower plants, you connect them to where they need the power. And this is one proposal. There are many, many different ways of doing this, but you'll see that there are power plants in Manitoba, for instance. There are three little lines there, and I'll get back to that in a moment. There are three little lines going from Nelson River to Alberta, for instance. There are two lines coming in from James Bay, the Nottoway Broadback area, into Ontario. There's Muskrat Falls that has two lines overland in Quebec. This was done before the Muskrat Falls proposal, undersea proposal. And in here we have provided for the possibility of bringing in power from the tidal potential that's in the Bay of Fundy and so on. It's a notional exercise. We're not saying that this is absolute truth with a capital T. But we asked ourselves, what would it take to connect the isolated power to where they need the power to replace that thermal generation? And this is one of many possibilities that could do it. Now, we asked ourselves, how could we cost this? So what we did, we said, let's use 735 kV transmission, which is prevalent in Quebec. Now, Quebec has 12,000 kilometers of 735 kV transmission. So we said, if we were to do this with 735 kV transmission, how many kilometers of line would be necessary? And by the way, 735 kV has roughly a 2 GVA capacity per line. That's the surge impedance loop. So you look at it that way, and we came up with the solution that you see here that is 17,000 kilometers in length. So interconnecting all of Canada in the way that I've just suggested by decarbonizing the electricity system generation would require, if we were to use a 735 kV solution, 17,000 kilometers of line. Is this off scale? Quebec already has 12,000 kilometers. It works fine. So we said, okay, how much would 17,000 kilometers worth of line cost? Well, it would cost about $51 billion, including compensation. It costs about $26 billion to build the lines, another $26 billion for compensation, roughly speaking. So that's another notional big project. This is all very controversial, I recognize. Oil sands. Now, this is a really, really interesting conversation because I think this is something that could be done in Ontario right now that would bring enormous wealth to Ontario and help bring its economy back to where it needs to be. And here's how. If you look at the bar on the left-hand side, that little bar on the left-hand side is the 2009 exports in synthetic crude oil and bitumen. That is a $30 billion a year export economic value. 80% of that is synthetic crude oil because until 2000 and early 2000, the companies in Alberta did build their own upgrading facilities to take the bitumen up to synthetic crude oil because they weren't sure that anybody would buy bitumen. So they had to upgrade it themselves. So in 2009, 80% of the bitumen was upgraded into synthetic crude oil, representing $30 billion of economic activity. We already know that in 2019, when we see what's been invested in the oil sands for production capacity, by 2019 there will be approximately $105 billion worth of bitumen and synthetic crude oil, but that will be on the order of $20 billion of synthetic crude oil and $85 billion worth of bitumen that's being exported. Now this is raw energy resource. If we were to, so this is the second part. If you were to upgrade all of the bitumen to synthetic crude oil, that's the next bar. You take that value up from 105 billion to 125 billion. You add $20 billion. If you were to upgrade that synthetic crude oil, all of it, to fuels and other oil products, you bring the economic value of that set of products to $165 billion. So the difference between selling mostly bitumen at 105 and all of it in terms of value-added products is $60 billion. Can we afford to lose $60 billion a year of economic activity? Now, it doesn't have to be in Alberta. And this is the most amazing thing to me that most people don't know about. In Sarnia, there's an oil pipeline that comes in from Alberta. It has the capacity to feed another refinery in Sarnia. A refinery is a $15 billion construction project. With the right environment, private industry will build it. And then we'll sell gasoline to ourselves and others rather than having to import gasoline from other jurisdictions. Why don't we do that? We're building cars, as fast as we can build them, but we're completely ignoring how we're going to feed these cars for the next few decades. Now, I don't like the idea of adding to our carbon footprint, but I don't think that we will be able to correct our carbon footprint from a position of poverty. So that's why I believe that this is a good project. It could also be upgraded in St. John, and if we don't do anything about it, the largest oil refineries in the world is in St. John, New Brunswick. I don't know if you know that. The bitumen could go to St. John. So, but in reality, we need both. We can build a refinery in Sarnia, we can upgrade St. John. There would be wealth for all of Canada. It would have a tremendous cascade effect throughout Canada. And that's another characteristic of great projects, they cascade throughout the land. It's a multi-jurisdiction thing. Nuclear energy, what we're proposing is that we do small modular reactors to reduce the carbon footprint of the oil sands. Biomass, huge low GHG untapped resource. 12 megatons of lumber a year are not presently being sold, and we're piling it up due to reduced demand in the US. Nearly 5 megaton of dry wood residue from a year from all of the lumber operations. 30 megatons of agricultural residue per year. 58 megatons of manure a year, which amount to about the amount of energy of 3.5 megatons of wood. 15 megatons of dry biomass municipal waste per year. Nearly 400 megatons of trees a year for the next 10 years due to the pine beetle infestation of BC. All of this is carbon neutral. We are not leaving this on the table. We are absolutely blind to the potential of transforming all of this through a variety of processes into anything from energy, heat, to chemicals and plastics. We're leaving it on the table. Maybe we're just too wealthy. Maybe we're spoiled. Gasification. This proposal is simply about the survival of the coal industry. If the coal industry is going to survive, it cannot continue providing a product for combustion the way it has for the past 150 years. It has to do something else. Gasification is a way of reducing the carbon impact, the carbon footprint of coal through a variety of through gasification, where you simultaneously produce electricity, heat, hydrogen, and carbon monoxide. That's called syngas for most people, and a very, very pure stream of CO2, which can be used as a feedstock for other value-added processes, which employ photosynthesis. But there are many nanotechnology-based processes today that look at CO2 in order to transform it into value-added products such as carbon fiber. And that is an excellent way of sequestering CO2. And the next step will simply be to pump it out of the sky like we do nitrogen to make fertilizers. Well, we can, the quantum obstacle to doing that chemically speaking, is much higher. But there are people actually looking at that. And that is the real solution to the depletion of CO2 in the atmosphere. LNG. We have a lot of natural gas in Canada that could be exported. And why would we export natural gas? Why would we have liquid natural gas terminals in Canada? Well, first of all, China and India will pay up to 4 times the domestic prices for natural gas. Why would we not seize that opportunity? Why would we leave it up to the Americans? Why would we not generate wealth, opportunities, tax revenue, and invest in equality and continued quality of life in Canada? And of course, natural gas is much more effective than coal in combustion. The result would be to move us from being an energy superstore to a sustainable energy superpower on this graph of resource asset capability versus impact. Now, you'll say, what if we just did things to be self-sufficient? We can do that, but it doesn't seize the full value of the asset. And it's unclear whether just by being self-sufficient we will have all the job opportunities, all the government investment opportunities to create the technologies that will help us deplete CO2 in the atmosphere in the next decade. I think we've got to nail that down the next decade. It takes money, and presently Ontario doesn't have the money to invest in those kinds of technologies. So the question is, do we stand still and lose ground, or do we surge forward and do something about building our country? If we were to do everything that we're proposing in this book, presently our carbon footprint, our energy, this is not carbon footprint, but rather it's an energy spectrum. 80% of the energy that we consume in Canada is hydrocarbon based in one form or another, as you can see here. And we're producing almost 8 megabarrels per day of energy. If we were to do the things that we're proposing here, we would double our energy output by 2050 to approximately 15 megabarrel per day equivalent energy, and yet Canada's carbon footprint would reduce to 50%. And if you're interested in the first project for which we in the Academy are preparing a conference on, well, in Sarnia in May 21st and 22nd, there is a conference entitled Bitumen, Adding Value, Canada's National Opportunity. This is the first of a series of conferences that the Academy hopes to have on each one of these big projects. I'd like to thank you for your kind invitation to speak to you today. I hope I provoked you a little bit. I know all of this is very controversial. When we were writing the book, I can tell you that the people that we had authors that lived in Sarnia, and when a different author proposed that we put a dam in Sarnia, nobody wanted the water level such that they lost their beach. So, you know, I'm deeply aware of, just by going through this exercise, of the kinds of adjustments that people might have to make. But I also believe that we have a lot of nation building that we can do, and this is the Canadian Academy of Engineering's proposal. Thank you so much for your kind attention. I'd be happy to answer questions if you had any.
It sounds like you're on a roll. Why are you moving to Memorial University in June?
Oh, it's well, thank you. That's very kind of you to say so. I've been in Ontario for almost 8.5 years, and many of you may not know this, but I may not be the founding provost and VP academic of UIT, but I came at a year and 3 months after it opened its doors, at a very critical period where things were very fragile, and the funding fell out of the bottom, and so on and so forth. And of course, my founding president neglected to mention all these interesting little facts when I arrived. But the key to survival for UIT, I thought, was to focus on doing the very best with the means at our disposal. I saw it as a startup, and I ran it like a startup. We had to pay a debenture every 6 months, and every 6 months after we had paid our installment to the debenture to pay for our buildings, we had a 6-month runway where we didn't know whether we would fall over the edge of the cliff in 6 months' time. But if any of you have ever been in a startup before, 6 months is an eternity, and having a team and structure and processes and pioneers that want to build something alongside you for 6 months, well, that's enough for a lot of people. It was enough for me. It was enough for my team and all of our professors. And in 2011, the government made us whole again, and we're here because we've proven that our graduates are as good as anybody else. And after having been through that, I didn't want to leave. I love it at UIT, but Memorial came and knocked on my door, and they just wouldn't take no for an answer. And that's why I'm leaving. Yes?
If I could just interject, can you say your name and state maybe your affiliation? It's just being taped, and there's microphones around here. I'd be remiss if I didn't mention that, because remember who drives the program. So, if you can, just state your name and your affiliation if it's possible, because we're taping it, so I will know who's who and what's what.
It's Henry Bohovic from Mine First State, also on the investment committee at SDTC, and I teach a course in energy systems at the UT. Lots of interesting mega projects. I'm wondering if you could comment or you thought about the political appetite for the price tag on some of these. Most of them, the price tag is in tens of billions of dollars. The thought occurred to me where you showed how in the past governments played a key role, and now it's all in the private sector. But part of the reason might be that most jurisdictions are essentially insolvent, and most of the money is in the private sector. So that may be a determining factor. But if you could talk about how you think some of these things might get funded.
This is a very good question. I'm glad that you asked that question. There are many parts to this. So let me begin with where we often like to begin in Canada. We like to think that there's a framework, there's a policy framework, there's a strategy in energy. There's some sort of guiding principles that will guide whatever it is that the country will do. And that sort of fell apart in the energy area in the late 1970s, early 80s. For decades, our Alberta cousins didn't want to have anything to do with a national energy policy. I would say that presently it is the people of Alberta that are asking for a national energy something. I think that's a fairly valid statement. However, I think that after having gone through many negotiations in Constitution, in the constitutional area, in the health area, and so on over the past 2 decades, the federal government is averse to creating frameworks or to establishing policy or to having some sort of strategy. So what we in the Canadian Academy of Engineering are proposing is we don't need strategy. We don't need policy. We don't need frameworks. All we need is for the partners that are the key stakeholders of a particular project to come together and to establish how they're going to work together to make this happen. That's why we're talking big projects. And there are other big projects that one could propose. And in fact, since we've published this book, a number of authors have come forward and have suggested a number of other projects. And we're working on a 2013 edition by the end of the year, with another half dozen other big projects. For instance, in the district energy geothermal area, for instance, and another one in the nuclear area, and so on. So there is, and yet another one in the hydroelectric area. But so the idea is, the subliminal idea, if I can put it this way, from a very personal perspective, is let those stakeholders, those partners, come together over a project. Let's hammer out the details over this project. Now, if it's two provinces in the federal government and private enterprise, or if it's a province and a private enterprise, or whatever it takes, but as small as you can make it, the smallest number of partners that need to be at the table to make it happen, that's what is best. So the principal idea is, let's do big projects. They have a cascade effect on the entire country. They're multi-jurisdictional. And let just those jurisdictions who have a stake in getting this off the ground sit down, negotiate, and get it done. Now, once we've done one big project and maybe a second big project, there may be enough in there in 2 points on a graph to begin to generalize around some policy framework. But let's forget about building frameworks and policy and strategies. Let's just sit down and get it done. And that's our position in the Academy.
It's like Nike, just do it, right?
So if Suncor, who has a refinery in Sarnia, were to go to the Ontario government and say, we would be willing to invest in a refinery. Now, I don't know that they do it because they've got a stake in a big refinery out west already. They've invested $5 billion out of 15 for a big upgrading facility called Voyageur that they've suspended right now. But let's notionally say that if Suncor felt that this was a better economic proposition than building in Alberta, why don't they go to the Ontario government and say, if you gave us this landscape, we would be willing to invest $10 billion in an upgrading facility in Sarnia, because we're on the Great Lakes, we can upgrade and send our upgraded value-added products to the world because we're on the St. Lawrence Seaway, on the Great Lakes. We don't have to load them onto a train and then onto a boat. We don't even need a pipeline. We're there. You help us create this refinery, and we will bring billions of dollars of yearly economic activity to Ontario. But you need leadership for that. Somebody has to break the mold and say, who's going to talk to who?
Just a quick question. I'll stand by the mic for recording, but I'm a graduate student at McMaster. Do you think that, in context of you're using history, that your projects in a sense are too small, which might sound weird, but when you look at, you mentioned transportation as being a major investment. And that certainly was the case with the railway and the canal system. But if you look at the investment that Canada made, it nearly bankrupted them. But it was attuned to, I think if you would kind of proportion it to today, it would be like $200 billion or something like that. So do you think 10 billion is enough? To just as a start, like, you know what I mean? Like railway, like we own, I think Canada owns almost half of the American rail network. And that's a success story for sure. But the cost was much more significant than some of the projects you're proposing.
This is a very good question, Ben, and I'm delighted you asked it. So I can only offer a very personal testimonial here. I'm an electric power engineer. And so I believe that there would be great merit in creating a national grid. In telecommunications, we have an integrated interprovincial telecommunications network since the late 1950s, since 1958 in fact. And arguably speaking, 100 years ago, that would have been far more difficult than integrating electric power, arguably speaking. Today we have yet to have greater connectivity between the provinces. The grid network is $50 billion, roughly speaking. Another, to create 35 gigawatts of hydroelectric power, that's another $50 billion. Is $100 billion big enough for you? That's one project. But realistically speaking, I think we need to have, again speaking as an engineer, the step-by-step approach is a better approach. When you go into high-risk projects, and every one of these projects is high risk for all sorts of reasons because they are all deeply controversial. So, some of them, like the St. Lawrence Seaway, will require having a lot of people at the table, the First Nations people. How many municipalities? How many environmental representatives? And so on, before anything gets done to just restore levels that had been there before. In the late 1950s, when we built the St. Lawrence Seaway, villages were drowned, cemeteries were drowned, but people expected that other people would do that in the name of what we called progress at the time. And our society is no longer there. So each and every one of these projects is deeply, deeply, deeply controversial. The question is, however, whether it's biomass, whether it's nuclear energy, whether it's oil sands and upgrading of oil sands, bitumen, whether it's gasification of coal, whether it's, I would love for somebody to come forward and in our next edition and formulate a proposal for depleting CO2 in the atmosphere. And that would be big. But that would be constructive. And that's exactly the kind of project that the world needs. I'll give you my own personal view on CO2 in the atmosphere is very much like transmission. You can see, I'm an electrical engineer, love power transmission, so I'm going to give you a transmission metaphor. You've got sources of CO2 that send CO2 in the atmosphere, and you've got loads of CO2, sinks of CO2 that absorb CO2 in the atmosphere. The atmosphere is a transmission system of CO2. If there is too much CO2 in the atmosphere, that is a risk to life as we know it because it creates climate change and it changes all sorts of things, releases more CO2. It's almost a runaway system that we need to control in some way. So by having too much CO2 in the atmosphere, you put life as we know it at risk. If you have too little CO2 in the atmosphere, that too, it puts life at risk because you can't generate the food that you need to maintain life as we know it, whether it's ourselves, animal species, the flora, and so on. So there's a small band of densities of CO2 in the atmosphere that need to be transmitted, that need to be there for life as we know it to maintain itself if we don't want things to change and grasshoppers to become human beings and replace us. So what in electric power transmission, what do we do when you've got too much of something, too much voltage, for instance, or too little voltage? We have compensating devices that do something to the power system to bring the voltage down or to prop it up. What we need in our CO2 transmission system is compensating devices that will, at the present time, take CO2 out of the atmosphere and sequester it in solid form. But to pay for that, that solid form has to be a value-added product. It would be great if somebody could write an article on something like that.
opening point here. Jan Carr, I'm retired, but I formerly was the CEO of the Ontario Power Authority and Vice Chair of the Ontario Energy Board. So I have had personal involvement with quite a few of the things you're talking about, Richard, and in particular efforts to essentially connect the Churchill Falls hydroelectric power into Ontario. What I conclude from that is endorsing very much your concept that we need to do things incrementally. And I would point out that the national grid is beginning to come together incrementally.
Yes.
You mentioned already the undersea cable from Newfoundland to Nova Scotia. That's not a done deal. In fact, it's in regulatory hearings as we speak. That project may wind up being a model for the question about how we finance things. Because in that case, the federal government is taking a very important but very minor role.
Yes.
In fact, it's only a loan guarantee. It's not
Yes.
even writing a check.
Yes.
It's just saying, if worst comes to worst, we're here.
Yeah.
They're making the project bankable in financial terms. The danger of that, though, and this is the point of my question, sorry, is that it's not visionary, which is, as the last person asked, that doesn't sound like a national grid. I mean, we know, and as an engineer, you certainly recognize it as being a part of it and a contributing factor. And with 3 more projects like that, 4 more, we actually have a national grid.
Yeah.
But they don't create that kind of buzz, which I think perhaps the Canadian Pacific Railway did, possibly the Victoria Bridge.
Yeah.
Parliament Corporation, I'm not sure, because that was in the middle of the war.
Yeah.
And buzz was not
Yeah.
encouraged, right? And so on. So I wonder if you've obviously debated this much within the academy. It's sort of like, the sizzle versus the steak here.
Yeah.
You got to have both, really,
Yeah.
for the thing to happen. So.
Again, Jan, thank you. That's a very, very good question. And the concept of buzz is a very important concept. And there are many ways of looking at this, I guess. And I'm not an expert in buzz, so I'm going to be making more like intuitive remarks rather than professional remarks on the concept and the art and science of buzz, but I think it's a very, very important concept. There are projects that intuitively create buzz, and probably in 1867, when the country was coming together, and this very, very, very outrageously ambitious project of having a continental railway system coming together, that was so far ahead of their time that it no doubt must have been a very exciting project for a lot of people. I don't know that energy in any of its form create a lot of buzz for people today. Are we spoiled? Are we on information overload? Is the signal to noise ratio too low? In other words, I'd be tempted, my own personal opinion is that the signal to noise ratio of really, really important information with respect to the white noise and everything else that we listen to every day and that we read and so on, it's far too low. So nothing really stands out anymore. But because we're on information overload, we're very reactive. We're not proactive and perhaps not reflective enough, except after we've come home from the holidays. So what I would suggest is that if I go back to the 1950s and the Trans-Canada Pipelines example, that one had there were a lot of people with very different views on that one. And I think it's a really, really good example of what happens today. In the Trans-Canada Pipeline debate of 1954, There are people who were totally against pipelines for environmental reasons, even at that time. Didn't trust them. There are people who wanted pipelines but didn't want them in their backyard. Were fine if they were somewhere else. There are people who thought that it wasn't an economically viable crown corporation. There were people who said it's a great idea, but for heaven's sakes, let's not get American money to do it. And so that's basically the landscape of 1954 to 1958. And in 1957, I think, the government fell. The Louis Saint Laurent government fell and ushered in the Diefenbaker years. It eventually got done because the Saint Laurent government managed to put in place the Crown Corporation and the structure and the government commitment to get it done. But it did so at a point where, for whatever reason, the Diefenbaker government didn't decide to put a hold on it completely. So I think it's something, I'm sorry to say, but maybe what we need is people with enough, who are tenacious enough to hold on to that particular dream and work hard to get things done despite a lot of opposition. And if we can create buzz, that's the ideal situation. But if we can't, I think we need real leadership. And I think that people will recognize and respect initiatives that are clearly meant to be in the public interest. I think that people will say, I disagree with that transmission line, or I disagree with that pipeline, or I disagree with this change in the flow of the river. But I understand why they're doing it, and as long as there is no corruption involved, and as long as the processes are squeaky clean, and as long as they're everybody understands that what we're debating is ideas, and the processes are above reproach, I think we can eventually get it done. But it takes a lot of leadership, and it takes a few years off people's lives, I'm sure.
Richard Chataway, I too am a retired engineer. We're very fortunate in this country to have two national media, the CBC and the Globe and Mail. And just talking to ourselves, while it's very valuable, it doesn't get a lot of things done because, as somebody has mentioned, the financial people aren't here, the environmental people aren't here, et cetera, et cetera. It seems to me that you just have to develop contacts in those two big media. And I think our engineers, I'm very hopeful that our engineering association is working on that. Because, we're trying to establish engineering ideas as very important ideas for the country.
Yes.
And you're not going to do it just sitting in a room like this.
I'll only say, Richard, that you're absolutely right. It may interest you to know that this book was launched on May 21st, I believe, as a special supplement of the Globe and Mail. And then it was released in paper form in early June of last year. It's presently downloadable for free from the Academy website, and it was clearly indicated as downloadable for free in the Globe and Mail supplement of May 21st last. So it's we do what we can do, but the Academy is not a wealthy group of people. It's just a small group of 500 or so fellows. And the only thing that finances the Academy is membership dues. And we stretch every dollar that we've got to try to get our ideas out there. But at least we're doing something. And yes, when I come to a group like this, a part of me says I'm speaking to, by and large, the converted. But the idea is to try to create that interest, to create that buzz. And I actually say, Richard, that maybe these projects aren't the right ones. But the idea is to start thinking, well, what if you don't like these, what ought we be doing? What could we be doing? Maybe a $10 billion or a $1 billion project is too big, but what could we be doing that will have maximum impact, and thinking about the higher interest of the country? And really that's what we're talking about here. I'd like to bring it back to nation building and how big projects in the past have contributed to building our country. And that's the conversation that we're trying to have here.
Very effective.
Hi, Richard. Paul Macchioni of the Ontario Society of Professional Engineers. I guess one of the things I've been noticing over the years is that governments are becoming less ambitious. They've become more conservative in terms of what they want to take on in terms of risk, and they're trying to transfer risk to the private sector. But when we talk to the private sector, they want the government to take the risk.
That's right.
And so a lot of projects that are what I call very impactful, both in terms of economic development or in societal benefits, never move forward. And when somebody has tried to do something more impactful, it sometimes costs them their job.
Yes.
Poor old McGuinty tried to go green, and it just about killed him. Probably did. And one can argue that maybe he didn't implement it properly. He didn't talk to the engineers first, because it would have been easier to implement it in a different way. But how do you get government to be less concerned about re-election and more concerned about moving the society forward? Because I just don't see a lot of priority being placed right now on governing bodies, whether provincial or federal, whether conservative or liberal or NDP. They seem to be more, in general, more concerned about making sure they get re-elected than making sure they do the right thing going forward 20 years.
I think that fear of failure is a significant contributor to what you're talking about, Paul. And how do we get people to be less fearful of failure? My sense is that most politicians go into politics with a lot of ideals, and very rapidly the system brings them to think about other things. I was speaking to somebody very close to the political arena 2 weeks ago, and this person said, the minute a government is elected, it starts working on the next re-election. And I had this sense that was true, but to hear somebody very close to that area say that is the way it really works is a bit. It's a bit disappointing, as if that was the only thing that mattered. But I think that maybe I don't have a solution for what you just said. All that I can say is perhaps fear of failure is the key issue. And I think we need to identify people who really want to put nation building ahead of all of the things and not get distracted by a lot of other things. But they will be distracted by a lot of other things because there are great demands put on our federal politicians, our provincial politicians. We expect them to be in their riding, meeting professional associations, meeting all sorts of constituencies and stakeholders, and yet do their job. And I think there's a fundamental disconnect between the ability of somebody to do the real job of leading the nation and not getting any sleep, and then basically being taken by the hand and going from one place to another to continue to meet the stakeholders. I think we've got to give them the chance to get some sleep, to reduce their fear of failure, and to come back to their origins of why they wanted to get into politics in the first place. So how to do that, I don't know.
Jordan Max from PEO. What I suggest is that these kind of 21st century problems, challenges that we face also require 21st century approaches, new models, new ways of going about this. Again, not relying on government to kickstart this, but for example, do we need a bit of a national partnership level of a steering group or something to sort of seize this and put it forward as a series of challenges for the country to sort of gravitate and grab onto? Do we have to look at an open innovation kind of approach at crowdfunding instead of at the macro level, but also a micro level, to get people feeling invested as citizens into these kinds of things, as well as companies or investing in companies that are going to take on some of the financing for these things?
That's a very, very insightful comment, Jordan. I think you're right. The 21st century approach to things, it's easy to say. It's not so easy to conceive, but we must do violence upon ourselves to be careful about reproducing our patterns from the 20th century, the 19th century, the 21st century. I'll give you an example, and this is a personal shtick of mine, but I may disappoint some of the civil engineers in the audience, but I deeply believe that the 407 extension in Ontario is a 20th century discussion. Why would we build a 407 in the 21st century when we've got Lake Ontario and we can buy a hovercraft to bring people to and from all over the Golden Horseshoe and beyond? And it's out now. You'll say he's definitely over the deep edge, but Europeans do this all the time, and we are constrained in so many ways around Toronto about getting people in and out of Toronto that maybe we do need to rethink our 20th century premises. We can't give the 20th century dream society of the mid 1950s to everybody in the 2050s. The carbon footprint's going to be too high. It's going to cost us too much, and we're not in a period of economic growth that we were in the 1950s. So we've got to rethink our premises, and I think you're absolutely right. You're inviting us to do so. So I can't agree with you more.
Keith Rivers, Babcock and Wilcox. I'd like to make a comment on your presentation. Having been personally involved in the energy industry in a number of the areas that you talked about, oil sands, nuclear, power generation, I'm very excited by what you're proposing here. And I think that it's important to, capture that sense of pioneering and vision. And I think you've started to do that in terms of what you're saying. I also endorse the idea of working on smaller projects, if you will. Just one example that I can give you from our own industry that has developed along those lines is we brought together some stakeholders in 2004 with the utility out west, and we're now at the point of developing, we're in construction on a project that will reduce the greenhouse gas emissions from a power plant in Saskatchewan from conventionally firing coal to the natural gas levels. And so that was something that was developed between government folks,
Yes.
The Canadian roadmap for coal people, the research people in Ottawa, industry, several different players, and the utility themselves. And so it's a rocky road. It's not easy, but it can happen. And so I encourage people to grab that vision and to work within their own areas, to push things forward like that. So I thank you very much for your comments.
Thank you very much, Keith. And listening to you speak, it dawned on me that maybe there is an answer to Paul's question as I listened to you speak. And the answer may be that politicians today, rightly or wrongly, follow public opinion. What if we could all influence public opinion to say, we want our politicians to lead us, than to propose visions of the future? What if we told our politicians, we don't want you to follow us, we want you to lead us and propose things? Maybe that would bring the pendulum back.
All right, seeing no other questions, and I'm sure if you've got a few minutes to spare, if there's anybody who wants to have a private session, or maybe sometimes what I find is engineers are afraid to speak their mind. So I think one of the things I'm going to take away from this is it's right in line with our May 31st. You got Steve Paikin telling us what keeps